All right. So in beginning to talk about population growth, we graphed some stuff. We graphed specifically a bacterium, right? We said that that bacterium reproduces under ideal conditions every 20 minutes. You gave me the numbers that there would be after 2 hours and then after 6 hours. And it turned out there was some fairly simple math we could do to predict that. And then I taught you how to use a spreadsheet. We use a couple of tricks to make your life easier. And some of the mathier of you immediately recognized the bacterial growth pattern as what's called exponential growth. So let's draw just a no numbers curve in your notes so we know the pattern. And if you had to pick a letter of the alphabet, what letter would you pick for that curve? What do you think? So that was a letter. An exponential growth curve is a letter. X? No, like what? Like the shape of the curve. What letter of the alphabet is the shape of the curve?
J.
Yeah, J. We call that a J curve sometimes. Sometimes we call it exponential growth curve, a J curve. So exponential growth is what happens. Turns out to be a pretty universal phenomenon that happens whenever any living population has all the stuff they need. Because what happens when they have all the stuff they need is they go right into a constant reproductive rate. Whatever their max reproductive rate is, that's what they do. And whether that rate is every 2 months or every 5 years, if they keep reproducing at a constant rate, they'll have a doubling time. And that doubling time means they're growing exponentially. It means we're going to go into that J curve. J is the shape of the curve, we call it. But something should bother you a little bit about what you just wrote. Something should kind of not quite ring quite right in what you just wrote. What is it? What up there sounds like, oh, does that really exist?
Unlimited resources.
Yeah, when we call something a resource, we're sort of saying, almost implying without saying, that it's a finite thing. A resource is something that can be depleted. It is not unlimited. So the thing about exponential growth is this. It can't go on forever. It doesn't go on forever. Because something runs out or something catches up. Whatever that first thing, by the way, that runs out, whether it's that there's so many that now the predators have an easier time of it, or whether it's that they're so packed in that disease thins them out, or more typical things like the competition among them just gets so steep, the death rates go up, or that they run out of space for water or food. Whatever that first thing they run out of is, or whatever the first thing that keeps them from getting bigger, you already have some experience with the terminology. If it's a plant and it's a chemical they run out of, we call it a... Sam?
Oh, that's fast.
Call it a limiting nutrient. If it's not, and it's not necessarily a chemical, we just call it a limiting factor. So predators can be a limiting factor. Disease can be a limiting factor. Sam, what's your question? You'll find out. We're going to graph humans soon. Yeah, and we'll talk about that for sure. It's interesting. A little scary. So the classic logistic growth curve is this. Logistic, you can kind of think of as exponential because it starts that way, doesn't it? But exponential after that's happened. We call it logistic growth. We call the line that is the start of the max once they reach their limiting factors. We call that the carrying capacity. The carrying capacity of that environment for that critter. So exponential growth, ideal conditions, unlimited resources, except no such thing. So real life, at some point, that exponential curve in its upswing is going to start to level off. Mostly it levels off because death rates increase because a limiting factor gets reached. So it always starts as exponential. And then as whatever resource changes, runs out, the growth slows and stops. What letter you want to pick for that curve? Exponential to J. This is called an S curve often. One way to think of a logistic growth curve is exponential, but after reality has set. And reality is that any environment can only support so many of any critter. You call that number the carrying capacity. Questions about exponential or logistic growth? So here's the question. If this is what's going on, if it's a logistic growth curve, and we're talking about rabbits in a field that are starting to, do what rabbits do and make more and more rabbits, and they get more and more crowded, do the rabbits just at one point look around and go, oh dear, we appear to be approaching the carrying capacity of our field. For us, perhaps we should stop making more rabbits. Is that how it works? It's not. Typically, reproductive rates stay pretty constant. There's a few species that adjust them based on conditions, but very few. Coyotes have been known to up their reproductive rate when they're being actively hunted. It's part of why they're so hard to get rid of. So this curve here, this is a mathematical curve, and I'll show you the formula for it after break. We'll actually work with it for a minute. It's basically calculus, so we can't do a ton with it, but you can at least sort of see what makes it tick. But this mathematical curve sure looks like those rabbits figured it out. If there's this nice smooth upswing and tapering off, it doesn't look like rabbits dying. So what I'll tell you is that in reality, a realistic logistic curve is a little messier. So I'm going to have you graph one. Grab your devices and open up that spreadsheet you created on Friday.
Where would be those?
There's numbers hanging down from the cabinet. Those are the ones that have Chromebooks out. You will be able to use the pattern trick for the first column. You just go 0 and 10 and then highlight them both and drag down until you get to 170. But the second column you will have to type in yourself. It is not a consistent formula or pattern. It starts out as one. but there's a few little differences in there too. So you'll have to hand type the second column. The first column you can auto do. Well, when you've got it all the data in, go ahead and graph it so you see what it looks like. So I didn't say this, but what I meant for you to do with this was to make a new tab on your sheet. You know how to do that? There's a lower left, there's a plus sign. So make a new tab. You could name the first tab exponential and the second tab logistic. So you got a graph. Remember, you just highlight the data range and insert chart. So what you're seeing is a much more realistic, real-life logistic growth pattern. What happens is not that they slowly approach the carrying capacity and decrease their birth rate because they realize they're getting too crowded. What happens is they keep having babies, and then a bunch of that species dies. There's a little mini crash, right? And then so they overshoot the carrying capacity, and then there's a crash, and they go back under it. And then they keep having babies, and so they go over it again. And what we see is sort of a bounce around the line. So let's go ahead and draw that in the notes as well. Sort of a part 2 here that says real logistic growth kind of tends to bounce around carrying. And that is about as far as we're going to get in chapter 5. Before break. I might add one little thing tomorrow. But post-break, then we'll continue to explore types of population growth. We'll look at humans and what that means. And then we'll look at sort of chapter 6 is all human effects on ecosystems. So what we do from here is get ready for the end of semester cumulative exams. I'm going to give you a breather today, and then tomorrow we're going to go over the test you took Friday, provided I can bust my butt and get it graded. There's a lot of writing. You guys wrote a lot. It's taken a while to grade, but you guys are done. I just don't have 9 and 10. And so we'll go over that test, and then I will give you your review sheet, which is very specific. I'm just going to say like that review sheet tells you exactly the topics of the essay questions you're going to have on the cumulative exam. It's going to be basically 9 or 10 essay questions, and I'll tell you exactly where I'm pulling them from. And you'll get to spend probably half of tomorrow's period and all of Wednesday's period studying, getting ready, practicing answering those questions. Clear? And then what, Thursday, we have class, but it's just 1, 2, and 3. So right after this period, Thursday, you'll go into your other exams, and then on Friday is when we'll have ours. That's right, isn't it? Say that right? Okay. Yeah.
So Friday after our variance, like a normal day.
No, after your 1, 2, and 3, you're done. I believe so. Yeah, that was the way I understood it.